So in this video we're going to play around with some more trig identities. And we're going to go back to the sign, oops, need a smaller pen stroke there, the sign of A plus B. Right, that is the trig identity where you mix the trig function. So it's going to be the sine of A times the cosine of B plus the sine of B times the cosine of A, which makes you wonder, well, what is the sine of A plus itself? Well, that's going to be, right, this is the sine of 2A's. What does that equal? Well, that equals the sine of A, cosine of A, plus the sine of A, cosine of A, which is just equal to 2 times the sine of A, cosine of A, and that equals the sine of 2A. So there's an identity for us. Right, we're going to keep expanding on these identities. And then we can wonder, well, what happens if we do, oops, that's not a good color to use. What if we do the sine of A plus negative A? So A plus, well, let's say negative x, why not? So that's going to be equal to the sine of A times the cosine of negative x plus the sine of negative x times the cosine of A. Now, from other videos we talked a little bit about why the cosine of negative x equals the cosine of positive x. It has to do with that with x is a even function, you can see on the unit circle, and the sine of negative x, right, that is different, it's an odd function, so that equals negative sine of x. So when we rewrite this first term over here, we get sine of A times we can write it as the cosine of x. And now, well, this is going to be minus sine of x, so it's going to be minus sine of x cosine of A. And we can keep going with this idea and think about, well, what happens if we have the cosine, well, I feel like that's good enough. We'll write this in a trig identity for this one for now. So two, maybe not new to you, but this is the understanding that I have between this trig identity and this trig identity right here. And now we can keep playing around. Let's mess around with the cosine. What if we have the cosine of A plus B? This is that trig function where you don't mix up the trig functions. It's going to be cosine of A, cosine of B, minus sine of A, sine of B. We can ask all kinds of cool questions. We can ask what's going to happen if we do the cosine of A, right, minus something else, minus B. Well, that's going to be equal to cosine of A, right, cosine of minus B, minus the sine of A, and then sine of negative B. That's a minus sign there. Well, now what's going to happen? Well, this first term, just like with before, the cosine of A is just A, and the cosine of negative B is equal to the cosine of B. Now we have minus sine of A, sine of negative B. Well, sine of negative B is just equal to the negative sine of positive B. So this, in fact, becomes a plus sine of A, sine of B. And that equals the cosine of A minus B. Right? That's another identity that we can use. Okay. Now, what about the cosine of 2A? Well, that's going to be equal to the cosine of A plus A, which equals the cosine of A, minus sine of A, sine of A. Well, cosine of A times the cosine of A is the cosine squared of A minus the sine squared of A, which equals the cosine of 2A. And that could be helpful, but we're going to keep playing with this trig identity, and we'll keep going. This time, let's rewrite stuff using, we're going to combine it. So we have cosine of 2A equals the cosine squared of A minus the sine squared of A. And over here we have one of the first trig functions, which is the sine squared of A plus the cosine squared of A is 1. Right, so that's kind of in the background, because what we can do is say, well, what happens if we solve in terms of cosine? So we subtract cosine squared from both sides. Sine squared of A will equal 1 minus the cosine squared of A. And then we can take that and plug it back into this formula right here. So the cosine of 2A equals the cosine squared of A minus 1 minus the cosine squared of A, right? It's plugged in sine squared of A, right, equals 1 minus cosine squared of A. And this is going to be equal to cosine squared of A minus 1 plus cosine squared of A, which means that the cosine of 2A equals 2 cosine squared of A minus 1. And I think if we wanted to solve this in terms of cosine squared of A, we could add 1 to both sides. We get the cosine of 2A plus 1 equals 2 times the cosine squared of A, but I'm going to divide both sides by 2. So you can say cosine squared of A equals 1/2 times the cosine of 2A plus 1. There's another identity. And of course we can keep going. What if we had, well, again, cosine of 2A equals the cosine of A plus A. We return to this one, and we had that cosine squared of A plus sine squared of A equals 1. So now I'm going to subtract sine squared from both sides. So cosine squared of A equals 1 minus the sine squared of A. Right, this is going to help us out. So 1 minus the sine squared of A equals the cosine squared of A, and the cosine of 2A equals this, which we said, well, the cosine of 2A equals 1 minus 2 sine squared of A. And what's going on there? Well, if we went back to the cosine of 2A, it was just, well, this equaled cosine of A, so it's cosine squared of A minus the sine squared of A. So just plugged in, instead of cosine squared of A, 1 minus the sine squared of A. That minus another sine squared of A gave us minus 2 sine squared of A. So there's another identity that could be useful for us. And I think we'll do one more in this video. I mean, we can keep going, but how much time do we really have? So in the next step, I feel like is, well, what the cosine of 2A plus, right, we're going to add this term, 2 sine squared of A equals 1. And then we have that, well, 2 sine squared of A, solving for that, we subtract cosine of 2A from both sides. 2 sine squared of A is going to equal 1 minus the cosine of 2A. We divide both sides by 2 and get the sine squared of A equals, right, 1/2 of 1 minus the cosine of 2A. And that goes back to one of our other identities before, which said that the cosine squared of A equals 1/2 times the cosine of 2A plus 1, right? similar kind of relationship. So those are identities that we can add to our toolbox. Hope that helped.